Hello children, this is your Vanashree ma'am. In my last class, I have taught you about matter. Then I have taught you the different types of matter. I have taught you about elements, and then under elements, I have taught you that you have metals, non-metals, and metalloids. Now I will teach you a very important part of chemistry, which is a basic part of chemistry, that is symbols of elements. Now the writing the name of the full name of the element practically becomes very difficult. It is very difficult to practically use the entire name of the element. Say oxygen, writing the full name of the element oxygen, OXYGEN. Okay, so that is why the need for symbols came into existence. Okay, so then these symbols were decided. Now we denote the elements with the help of symbols. So today I'll be discussing with you the symbols, and these symbols are the alphabets of chemistry, because if you have to write any element, you need not write the entire word, entire name of the element, but you can simply use the symbols. So these symbols you have to remember as long as you want to study chemistry. Okay, so let us start with the symbols. Okay, so hydrogen gas, these symbols you have to by heart and keep remembering. Also you have to, it is very easy to remember. For example, element, I'll write all the list of elements here and the symbol here. Okay, so now for example, hydrogen. So the symbol of that is given to hydrogen is H, the first letter. Okay, then cobalt. So these are all elements. Okay, cobalt. Now the symbol for this is given as capital C and O. That is, the first two letters are taken. Why first two letters? Because the first letter C is given to carbon. Carbon is given the symbol capital C. So that is why for cobalt we can't give you C again. So that is why we have used first two letters cobalt, capital C and small o. Okay, this capital letter and small letter you have to be very careful. For in case of small letter, if you write a big letter, it will become wrong, because capital C and capital O, CO, stands for carbon monoxide. You will learn after some time when you advance more in this chapter. Then, for example, aluminium. You know aluminium, you have aluminium vessels. So the symbol for this is Al, the first two letters. Oxygen, the our main source for us to be alive. Without oxygen, we cannot be alive, isn't it? So oxygen you must have heard, oxygen gas. The symbol for oxygen is capital O. That is the first letter of the name O. Then you must have heard nickel. It is a metal. Okay. Ni. Then calcium. You must have heard this word calcium. Symbol for it is capital C and small a, calcium. Okay. Then chlorine. Chlorine, it is a greenish yellow gas. Okay. When you grow further, you will be learning more about this gas. So capital C and small l. Then you have magnesium. It is a metal. Okay, magnesium, Mg. Okay, then manganese. So all these symbols are accepted throughout the world. These symbols are not that you can't say Meri Marji, I will not say for magnesium short form, I will not use Mg but I will use Ma. No. These are the symbols which are accepted throughout the world by all the scientists of the world. They have accepted these symbols. So these symbols, anywhere you go, these are the standard symbols which you have to use. You cannot change these symbols, right? Then magnesium is Mg. Then you have manganese, Mn. Okay. Then you have iron, that is Fe. So where from iron this Fe came? Because the Latin name of iron is ferrum. So from that word ferrum, Fe came here. Okay. Because you cannot give I for iron because I is given to iodine. Iodine has already been given the symbol I. Okay. Then copper. Now, copper water bottles are the in thing. You also must be having copper water bottles at home. So, copper Cu. Again, you might think, why not Co? Because Co is already given to cobalt. So, Cu is given based on the Latin name of copper, that is cuprum. Cuprum is the Latin name. You need not by heart the Latin names. You have to remember these common names and the symbols. Okay. Then gold. Yes. Mama has gold jewelry, right? So the symbol for gold is again Au based on the Latin name aurum. Okay, gold has in Latin gold is called aurum. From that Au symbol is given to gold. Okay, then silver. Yes, you have silver items at home, right? Silver is given the symbol Ag. Is also based on its Latin name argentum. Okay, then sodium. Okay, the symbol is again Na, which is based on its Latin name natrium. So you may again think why not S, because the symbol S is given to another element called sulfur. Sulfur has been given the symbol S. Okay. Then you have helium. Okay. Nowadays this helium bulbs also have come. Helium balloons, the balloons, air balloons which go up. You must have seen, na? They have either hydrogen gas or helium gas. It is preferably helium gas because helium gas does not burn. Okay, it's very safe. Anyway, we will learn more about it as you grow up. Okay. Then lithium, Li. Then beryllium, Be. Boron, B. Nitrogen, you know nitrogen is the maximum component of air. In air, you have maximum nitrogen in our air, atmospheric air. Okay, so N. Fluorine, F. Neon, so you must have heard those neon signboards, neon lights. So Ne. Then silicon, Si. Phosphorus, P, capital P. Then you have lead, Pb. Okay, that is also again based on its Latin name plumbum. Okay, Then sulfur, I have already given S. Then you have argon, Ar, potassium, K, calcium, I have already given you Ca. Calcium is very much needed for our bones, isn't it? So these are the some of the symbols of the elements that are often used. Okay. So homework for you is to by heart the symbols and practice the symbols and elements. Once I complete this chapter, I will give you a small test on these symbols. This is very, very important. These are the alphabets, as I told you, of chemistry. Without the symbols, you will not be able to write the formulae. Next step will be from chemical formulae you will be learning of compounds. Okay. So this is homework for you. Practice the name of the element and the symbol and ask your parents to take it up with you. Okay. Next topic that I'll be doing is compounds. Okay. Now, what is a compound? When atoms of two or more elements combine chemically in a fixed ratio, a compound is formed. Okay. When is a compound formed? A compound is formed when atoms of two or more elements combine chemically in a fixed ratio. Okay. So, we can define compound as a compound is a substance formed when two or more elements when two or more elements combine chemically chemically means not just mixing, they react with each other, combine chemically in a fixed ratio, in a fixed ratio. This is important. In a fixed ratio, then a compound is formed. A compound is a substance formed when two or more elements combine chemically in a fixed ratio. Now, let me take an example. Okay, water. Now, how is water formed? Water is a compound which is formed when oxygen and hydrogen combine in a fixed ratio. Then water molecule is formed. Water molecule has always two atoms of hydrogen and one atom of oxygen. So that is the ratio in which they always combine. Okay. So example. So water molecule, water H2O is the symbol. H2O stands for, this is the chemical formula. This is not symbol, this is chemical formula. Okay. Water is made up of hydrogen and oxygen. Hydrogen and oxygen combined in a fixed ratio. Okay. Then let me take another example, common salt. We use salt chemically. The chemical name of common salt is sodium chloride. Okay. So, common salt that we use in our food. So, the chemical name of common salt is sodium chloride. Sodium chloride, and the chemical formula for it is NaCl, because common salt forms when sodium and chlorine react. One atom of sodium and one atom of chlorine combine to form sodium chloride. Okay, sodium, one atom of sodium and one atom of chlorine, they combine forming sodium chloride. Okay, so another example I'll give you is say calcium hydroxide. Okay, calcium hydroxide. The chemical formula is CaOH twice. Okay, so it is made up of calcium, hydrogen, and oxygen atoms. So it is made up of three elements. It is made up of calcium, that is Ca, oxygen, that is O, and hydrogen, whose symbol is H. So all these three elements, when they combine in a definite ratio, they form calcium hydroxide. Okay, so a compound is always made of atoms of two or more elements. Now, a compound has properties that are different from the elements that it is composed of. Means, so the first point, okay, I'll come to it slowly. Now, till now, what did we learn? We learned that compounds are made up of two or more elements combined in a fixed ratio. The next point that we will learn, a very important point about compound. A compound has properties that are different from the constituent elements, that is elements which form the compound. A compound has properties different from its constituent elements. That means what? That means elements which compose or which form, let me use a easier word, which form the compound. Now let me explain this. What does it mean? Now for example, I have just told you water is made up of hydrogen gas and oxygen gas. Okay. Now, so these are the constituent elements. What are the constituent elements? Constituent elements of water. They are hydrogen, and oxygen. Both are gases. Okay. But water is a liquid. Yes or no? So water does not have any of the properties of individual properties of either hydrogen or oxygen. Water has its own set of different properties. Okay. So that is called that is the meaning of a compound shows properties that are different from its elements. Okay. So this is the meaning of this statement, that is a compound has properties different from its constituent elements. So water, which is made up of hydrogen and oxygen, both are gases, but water is a liquid, basic difference, okay, in the state. Then there are many other properties which individually hydrogen has, oxygen has. For example, oxygen gas supports burning. Okay, in the presence of oxygen only burning can take place, whereas hydrogen gas itself starts burning with a blue flame. These are the properties, individual properties of hydrogen and oxygen. But water does it support burning like oxygen? No, water does not support burning like oxygen. Water, does it itself burn with a blue flame like hydrogen? No. So the properties of water are completely different, isn't it? So that is the meaning of a compound has properties different from its constituent elements, that is elements which form the compounds. Okay. Then the third property of compound is a compound has two or more elements mixed together in a fixed ratio. Okay. Fixed ratio, I told you, like hydrogen and oxygen make oxygen water when they combine in a fixed ratio. That is called compounds have compounds have two or more elements combined in a fixed ratio. Okay. Then a compound is homogeneous, means I'll tell you, a compound is homogeneous. Homogeneous means uniform. Okay, like for example in water you cannot say here is hydrogen, here is oxygen. Can you identify its constituent elements in water? No. It is throughout uniform. It does not show the presence of either hydrogen gas or oxygen gas, but it is composed of hydrogen gas and oxygen gas. So that means a compound is a homogeneous. A compound is homogeneous means compound has uniform distribution of atoms of its constituent elements and has the same properties throughout. Okay, so in water you cannot identify, oh see, this is hydrogen gas, oh here it is oxygen gas. No, but those two gases have formed the water. But water has its own properties and throughout it is same, it is homogeneous. Okay. Then you have a compound cannot be separated into its constituent elements by any physical process. A compound cannot be separated, cannot be separated into its constituent elements. A compound cannot be separated into its constituent. Now you are familiar with these words. With this word constituent means the elements which form the compound. Cannot be separated into its constituent elements by simple physical means. Means what? A compound, that is for example water we have taken as an example. A water is formed by hydrogen and oxygen. But from water to get back hydrogen and oxygen is not simple. You cannot use simple physical methods like heating or by separating it with a funnel or anything like that. By simple physical means, you cannot separate the constituent elements which have formed the compounds. So a compound cannot be separated into its constituent elements by simple means. Similarly, as I told you, salt, that is sodium chloride, it is made up of sodium, metal and chlorine gas. But in common salt, can you see separately sodium, metal and chlorine gas anywhere? Can you separate easily sodium, metal and chlorine? No, you can only separate them by complicated chemical processes. Okay, water can be separated into its constituent elements by a complicated process called electrolysis. You will be learning in 10th standard. Okay, so by simple physical means, you cannot separate the constituent elements of a compound. Okay, then when a compound is formed, energy is either released or absorbed during the reaction. Means what? Sometimes, in order that the two elements combine to form a compound, either you have to heat those elements or you have to supply some energy. So that is called energy is absorbed during the reaction. Some reactions, they when two elements combine together, they release energy. Okay, so they, that is called, they energy is released. Okay, so for example, if sodium metal is dissolved in water, sodium hydroxide is formed. That time you will find that the solution or the beaker in which you are mixing sodium and water, the water which you have taken would have been at normal temperature, but when you add sodium and start stirring it, the beaker becomes warm. So that means what? While sodium and water are reacting, heat energy is evolved, heat energy is released. So heat energy is either absorbed or released during a chemical reaction. Okay, so that whenever heat energy is released, it is called exothermic reaction, and when heat energy is absorbed, it is called endothermic reaction. Okay, so the next property of compounds is when a compound is formed, energy is either released or absorbed during the reaction. Okay, during the reaction, energy in the form of heat, okay, is either absorbed or released. So if you have to heat a certain elements in order that they react, then we call energy is absorbed. Okay, then such a reaction is called exothermic reaction. So the reaction, you will be learning more about these reactions in 9th standard. The reaction in which, now for the time being, if you remember this much is enough, the reaction in which heat energy is given out or released. Such reactions are called endothermic reaction. Sorry, such reaction is called exothermic reaction. The reaction in which heat energy is given out or released is called exothermic reaction. You will learn more about it in detail in 9th standard. Okay, and the reaction in which heat energy is absorbed. Heat energy is absorbed means where you have to heat the elements or constituent elements for the reaction to take place. So the reaction in which heat energy is absorbed is called endotherm is called endothermic is called endothermic Thermic reaction. I'll just give you a small example. When mama heats rice in water, then only you get cooked rice, isn't it? If you simply mix rice and cold water, will you be able to eat it as your rice? No. So it is an endothermic reaction because you are supplying heat energy. Okay? But if heat is released, or when two elements combine, if heat is given out, then we say it is a exothermic reaction. Okay? So let me stop here, go through it, learn the symbols. Then in my next class, I will teach you chemical formulae of compounds. Okay? In the meantime, I will ask you to think about what is the difference between elements and compounds. Okay? I will discuss with you before I go to chemical formulae in my next class. Okay, children, so for you, homework is by heart or learn the symbols of the different elements that I have listed in this lesson or in this class. Okay, thank you, children, for watching the lesson. Take care, stay healthy. God bless you.